Attention, attention! Something very exciting is going on Saturn. It's called a spoke season, and no, the planet isn't turning into a giant gaseous wheel. Let me tell you more about this phenomenon. Each year, NASA's Hubble Space Telescope devotes some of its time to observing Saturn, a gas giant, like me, the second largest planet in the solar system. And this space body always has something new to surprise us with. For example, look at one of the latest images of the gas giant. See those smudgy spokes? They mean that Saturn's spoke season is starting. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. Keep this in mind, it's important. Now, the next thing we need to talk about to understand the concept of the unique spoke season on Saturn is the equinox. On Earth, it's the moment when the sun is exactly above the equator of the planet, and day and night are of the same length. But on Saturn, it's something a bit different. An equinox occurs when Saturn's rings are tilted edge-on to the sun. And even though equinoxes on Saturn happen every spring and fall, just like on our planet, they actually occur very seldom, roughly once in 15 Earth years. That's why astronomers are so excited about this event. Now look, there are 2 smudgy spokes in this ring. It's called Ring B on the left of the picture. They resemble the spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they might look like blobs instead of something with a classical radial spoke shape. They also don't last long, but more and more will start to appear the closer we're to May 6, 2025. That's when the autumnal equinox on Saturn will occur. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. On Earth, this results in northern lights, also called aurora borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders the rings consist of. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At the time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. At that time, NASA's Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. They quickly proved that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. That mission was finished in 2017. Now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon. Because even though other gas giants in the solar system also have rings, those are not so visible, and scientists don't know whether spokes occur on those planets. But these spokes aren't the only exciting space phenomenon. Our solar system is a fascinating place, that's why. If you were standing at the Martian equator barefoot, your feet wouldn't get cold. The temperature there would feel like on a sunny spring day on Earth. But you'd have to wear a hat. At the height of your head, it would be freezing cold. Now Venus spins backward compared to most other planets in the solar system and the Sun itself. One of the explanations astronomers have come up with is a collision with some solid object, for example an asteroid, that happened in the past. Jupiter's moon Io has hundreds of volcanoes, which makes the satellite the most volcanically active object in the solar system. The moon also has a weird yellowish surface. It looks blotted and resembles a pepperoni pizza. Yum. Europa, one of Jupiter's 4 biggest moons, is covered in ice. This ice shell can be 10 to 15 miles thick. It also has some smooth patches, so if you're into ice skating, you would like it there. If you lump together all the known asteroids in the solar system, their total weight would still be smaller than 10% of the mass of our Moon. Scientists believe that Mercury might still have a partially molten core. It could explain why Mercury has a magnetic field, even if it's just 1% as strong as Earth's. Mercury's core takes up around 42% of the planet's volume. Mercury also has wrinkles. When its iron core was cooling, the planet's crust contracted. It made the surface of the planet uneven. These wrinkles are called lobate scarps. The biggest of these scarps can be hundreds of miles long and up to a mile high. Uranus is the only planet in the solar system to rotate on its side. The reason might be an ancient mega-powerful collision with an Earth-sized object, but so far it's just a theory. Mars might get a set of rings of its own in the next 70 million years. Its largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. I won't be around then, so I'll just take their word for it. Scientists think that the Moon's surface has more craters than Earth's because it doesn't have so much natural activity going on. Winds, rains, earthquakes, and erosion keep altering the surface of our planet, but the Moon has almost no weather to change its appearance. Saturn is the most flattened planet in the solar system. It's squished at the poles, and any point on the equator is about 4,000 miles farther from the center of the planet than the poles. The Hubble Space Telescope weighs almost as much as 2 male African elephants and is as long as a big school bus. Yeah, that's a launch I'd love to see. 2 elephants in a school bus. It's made almost 1.5 million observations since it was launched in 1990. Astronomers have used this data to write about 15,000 scientific papers. Everything on Earth and everything people can see in space with the help of telescopes is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Almost 68% of the universe is dark energy, and the remaining 27% is dark matter. Does that really matter? As a matter of fact, it does. Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm, measuring almost 5,000 miles across. That's 2/3 the diameter of Earth. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. Saturn is also the only planet in the solar system that's less dense than water. In other words, if you found a bathtub huge enough to fit this gas giant, it would float there like a rubber duck. Earthquakes on the Moon don't occur as often as on our planet, but when they do, it happens closer to the center of the satellite. Scientists think moonquakes might be caused by the gravity of Earth and the Sun. One of Saturn's moons, Iapetus, has bizarre two-tone coloring. The difference between the Moon's two hemispheres is great. One of them is light and the other is eerily dark. Scientists haven't figured out this mystery yet. Now, the only asteroid belt in the solar system astronauts know about is between Mars and Jupiter. There are thousands of asteroids in this area. They're irregularly shaped solid objects of different sizes, but all of them are way smaller than a planet. Scientists have analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. Some of the rocks turned out to have a Martian origin. Others arrived from the Moon or the asteroid belt between Mars and Jupiter. Ooh, space rocks. So we can also say, space rocks. Yeah, we could say that.
Solar eclipses are amazing to witness because the Moon and the Sun seem to overlap perfectly in our sky, even though the Sun is way bigger, about 400 times. The trick is, the Moon is also about 400 times closer to our planet, so they end up looking the same size to us. Sadly, at some point during our planet's history, solar eclipses won't happen anymore. You see, the Moon is actually drifting away from Earth, sliding away about 1.5 inches every year. Because of this movement, the Moon will no longer completely block out the Sun. Experts at NASA went on to calculate when the last solar eclipse will happen. They say it's still going to take about 600 million years, so it's safe to say none of us will be here to see it. Speaking of things we won't see in our lifetime, we might need to add stars blowing up to that list. We know what stars look like when they fade away because of telescopes, but we've never seen one with the naked eye popping up above us. Betelgeuse might not sound like a familiar name, but know that it's a red supergiant star located about 1,000 light-years from us. What's special about it is that it might explode and put on a spectacle that's never been seen from down here on Earth. This star has always been a bit of a mystery in terms of when it's gonna pop. What we do know is that Betelgeuse is in the late stages of core carbon burning. And this carbon burning phase typically lasts around 1,000 years. Chances are we won't be seeing any stars collapsing anytime soon. But since this event will most likely be harmless for our planet, it's something exciting for future generations to look forward to. Also, if you're curious to spot Betelgeuse in the night sky, it's usually visible in January and February evenings, and by early August, you can catch it before sunrise. It's got this unique muted orange-red hue, perfect for showing skeptics that stars do indeed come in colors. Our planet will also suffer a lot of changes in the future. If we could travel some millions of years ahead, we might not recognize our planet's maps at all. Currently, Earth has 7 continents, but it hasn't always been that way, and it will most likely change in the future too. About 310 million years ago, Earth had this megacontinent called Pangaea. Around 180 million years ago, it started to break apart. Now, scientists think that in the next 200 or so million years, we might see another large continent forming. In fact, we might be right in the middle of this whole supercontinent formation. There are 4 main scenarios of how this new land could come to be, each with its own twist. They all link back to how Pangaea split up and how our continents are still shuffling. Our day, the 24-hour cycle we live by, is slowly stretching out too. This sneaky, gradual change will eventually lead to days that are 25 hours long. And here's why it's happening. Earth's rotation, that spinning we do each day, is getting a bit slower each year, and it's all thanks to the moon. That's because our satellite is sort of stealing some of Earth's energy. We know this is happening because of a cool gadget called the Laser Ranging Retroreflector. It shoots laser beams up at the moon, and when those beams bounce back to Earth, it takes a tiny bit longer for them to return. This little delay is a clue that our days are stretching. So, how much longer until we get 1 extra hour each day to finish up our to-do lists? Well, experts over at NASA did some calculations. Over the last century, our days got about 1.4 milliseconds longer. And if we zoom out and look past the 2,000 years, using historical records of solar eclipses, our day has stretched by an average of 2.5 milliseconds every century. Tedious calculations aside, we'll need about 50,000 years for a single extra second to be added to our day. That means it will take 180 million years for a day here on Earth to have 25 hours. That is, of course, if nothing else happens to our planet's rotation in the meantime. The Milky Way and one of its closest neighbors, Andromeda, are planning to merge somewhere in the future too. We won't be here to experience this interaction, but it probably won't feel like much of a change from down here on Earth. Galaxies colliding may seem a bit unusual, especially since we know the universe is expanding. If galaxies are moving further and further apart, how come they still get to meet with each other? Well, galaxies that are close don't just float around. They each have an effect on the other, thanks to gravity. That's the reason why the Milky Way and Andromeda are moving closer at about 186 miles per second. If we do the math, it means their collision won't happen for another 4.5 billion years, and chances are they're going to gently pass through each other, without visible changes being felt from within our solar system. There will come a time in the distant future when Saturn's stunning icy rings won't be here anymore either, at least according to some new research. NASA's Cassini mission, which spent its time orbiting Saturn between 2004 and 2017, gathered some new information about these rings and when they might disappear. You see, scientists have been debating for a while how old Saturn's rings are. Some thought they must be pretty young because they're still so bright and icy. They figured that over billions of years, they should have been worn down and darkened by all the space objects crashing into them. In fact, it's possible that these rings were still taking shape when the dinosaurs were roaming the Earth. When foreign space objects sneak into the rings, they shove material from the innermost circle towards Saturn at a pretty fast pace. As a result, Cassini saw the rings losing tons of mass every second. That means these rings aren't going to be visible for too much longer, in cosmic terms at least. They're estimated to last maybe a few 100 million years at most. We might also miss this next cosmic event, but barely. That's because according to some estimations, it might happen in just 100 years. The Earth's magnetic field might collapse, flipping its north and south poles. Researchers claim that for the past 3,000 years, our planet's magnetic field has been on a steady decline. And if this trend continues, we might hit a critical point in less than 1,000 years. For the planet's poles to switch, the magnetic field needs to weaken by about 90%, and this can take thousands of years. During this vulnerable phase, our planet loses its protective magnetic shield, letting in more cosmic rays from space. The last time this pole flip happened was almost 800,000 years ago. Problem is, we're currently in one of those riskiest phases. The field's getting weaker, but there's a chance it might regain its strength. At this rate of its decline, though, it could nosedive to nearly zero in just a few centuries, or a millennium. And we're already witnessing the effects of our weakening magnetic field on our satellites. In the vast expanse of the Atlantic Ocean between South America and Africa, there's a region where Earth's magnetic field is 3 times weaker than at the poles. Scientists call it the South Atlantic Anomaly. Satellites passing through this zone consistently face electronic problems. No one knows why this weak field region appeared in the first place, and predicting its future moves has been pretty inconclusive. One theory is that a massive swirling whirlpool in Earth's liquid metal outer core might be responsible, pushing the magnetic field away from the South Atlantic. Another thought is that the magnetic field in this region is pointing in the wrong direction, like a mini pole flip.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the 4th planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the Red Planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is Perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars. and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the Delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the Delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the Delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grain than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Well, let's go to Antarctica. Come on, you've got time. Remember to dress warm. Here we are, in the middle of endless snow-white plains and ice. The temperature in some places drops to a face-freezing -136 degrees Fahrenheit. It's so cold that if you throw hot water out of a mug, it will most likely land in the form of an icicle. But this cold is hot compared to the absolute zero definition. Scientists measure it on the Kelvin scale, where 0 is the lowest point, and that's why there is nothing colder than this temperature. All objects consist of atoms and molecules. When the temperature of any object rises, its molecules move quickly and chaotically, producing kinetic energy. If the temperature of an object drops, its molecules slow down in motion, and their energy decreases. So, absolute zero is when the particles stop altogether. There's no movement, which means it's impossible to make it colder. 0 Kelvin is equal to -459 degrees Fahrenheit, so that's like 3 times colder than in Antarctica. So, imagine that scientists created a vacuum room and filled it with gas at absolute zero. What happens if a human walks in there? I can't imagine that this turns out well, so let's send Bob in there. But don't worry, he's a crash test dummy. A little background first. When a hot object comes into contact with a cold one, its molecules exchange energy. Fast-moving particles transfer their energy to slower-moving ones and begin slowing down themselves. Then an equivalent exchange occurs, and the temperature equalizes. But by default, the molecules move quite slowly until they're charged with energy. And at the same time, if you have a heated object, you will need more power to cool it. Yeah, it's a bit confusing. So let's go back to where the fun begins. Yes, if you go to absolute zero, you will freeze in seconds, because all your molecules will start to slow down. But what will happen to the body? Well, let's follow the internal adventures of Crash Dummy Bob. First, its blood vessels narrow in the coldest places. The body distributes blood from frozen areas to vital organs, like the liver, kidneys, heart, and brain. It's like emergency mode. The mannequin's body stores energy and blood for the most important, taking it away from less important areas. Then, a most dreadful thing begins. The body consists of billions of cells. When their molecules come into contact with a cold temperature, they slow down and freeze. Remember what happens to water in a frozen state? Remove the bottle from the freezer and let it defrost at room temperature. You'll see that the volume of liquid will decrease after a few hours, and when the water freezes, it increases in volume. And the human body is more than half made up of water. So, inside our mannequin, its cells get covered with sharp ice crystals that tear the internal structure of the cells. The muscles and blood vessels of the dummy are torn. Its skin gets a dark blue shade, and its blood freezes in its veins. A couple more seconds, and the dummy freezes completely. Absolute zero temperature stops all internal processes. Hey, Crash Dummy Bob said he wanted to chill, but this is ridiculous. Meanwhile, molecules are not only in living objects. Particles are everywhere, and absolute zero affects them too. The rays of light get the lowest energetic position. Photons slow down, and they can't move at the speed of light anymore. Okay, now it's time to finish the experiment. Something's going wrong, and the story becomes fantastic and hypothetical. Scientists can set molecules in motion, and the neighboring moving particles don't give them their energy. For some reason, the gas can't absorb the energy. Its frozen molecules slow down the others. The gas penetrates through the walls of the vacuum room and starts a chain reaction. The molecules freeze one by one. It's like they take a nap and charge all the matter around with this sleep. The gas area is expanding. Laboratory walls, doors, and windows are frozen. Scientists are covered with ice. Then the cloud goes outside the building. It's like a white spot that keeps growing and growing. The sun's rays get there, but can't move inside too fast. The zero envelops grasses, trees, roads, and cars. Scientists begin to sound the alarm as soon as a whole city gets inside the absolute zero clouds. The stopping of moving molecules occurs so fast that ice crystals don't have time to damage the skin and body in living bodies. It's not even freezing, but canceling existing life. Oxygen and carbon dioxide molecules are frozen. The air gets denser. Here a guy freezes in a jump and remains in the air. Here a frozen bird continues to hang in the air. Things inside the cold air are similar to a 3D picture. Everything froze in motion. It's like someone took a screenshot of a lifetime and printed it. And while the cloud of absolute zero continues to spread, scientists are rushing to solve the problem. The gas is growing and diverging in all directions. If it swallows the whole Earth, it will stop all the chemical processes on our planet. And without these processes, our home will become just another space rock, a lifeless piece of matter stuck in time. However, the real catastrophe will happen not when it envelops the entire surface of the globe, but when it reaches the core of our planet. This can lead to the release of energy that will destroy the planet. Perhaps the core may resist the absolute zero, but in any case, people are not going to wait for this to happen. The cold gas meets a volcano. Lava flows emit a deafening hiss and freezes. Black clouds of steam billow into the air. The cold cloud penetrates into the volcano. The collision of cold and hot temperatures releases energy. The volcano erupts and launches not fireballs, but sharp icicles of frozen magma. Meanwhile, heavy rains are beginning to fall all over the planet. When warm air collides with cold air, it moves away because it has less density. The liquid appears in the atmosphere and it forms clouds. Therefore, while the giant cloud freezes one part of the planet, rain clouds drench the other. And now scientists have finally come up with a solution. They've created a gas with an altered molecular structure that can stop 0 Kelvin temperature. So imagine you're heating water. The stronger the water molecules increase their kinetic energy, the hotter the water becomes. The molecules are moving faster and faster, but not all particles move equally fast. Some of them have medium and slow energy. Moreover, the low energy state of the molecules is more likely. This means that only a few particles move really fast in hot water. This distribution of low and high charge particles is called the Boltzmann distribution. The distribution is everywhere, both in hot and cold objects. If we look at any object at the molecular level, we'll see that there are many more slow-moving objects than fast-moving ones. So, scientists have come up with a solution. They create a gas that works in the opposite direction. It has more moving molecules inside this gas than slow ones. Scientists hope that this gas will wake the sleeping particles up in the absolute zero cloud. So, two gases collide with each other. The cold cloud can't freeze the reverse Boltzmann distribution cloud. There are too many active molecules. So, billions of active molecules charge the frozen ones with energy. All the molecules start moving and share the neighboring ones with their energy. Objects inside the gas cloud begin to wake up. People are slowly coming to their senses. As soon as the molecules come into minimal motion, they start to receive energy from the sun's rays. The particle movement is distributed equally between the two gas clouds, and life returns to normal. The molecular order has been restored. Right. And our little fable here comes to a happy, if not entirely credible, end. Bottom line here, don't worry. Scientists created absolute zero artificially, and it'll never happen naturally. There's no such temperature anywhere in the universe. Particle movement remains even in space's farthest and darkest corners with record low temperatures. The appearance of absolute zero is impossible because there will always be molecules around that move and share their energy with each other. Oh, by the way, no humans, animals, or Crash Dummy Bob were harmed in the making of this video. Are the lawyers happy? Okay.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. the theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Hold on to your hats, folks, because we're about to embark on an incredible journey. With the help of super smart scientists and their studies, we've asked AI to take us back a mind-blowing 2 billion years in time and show us what our awesome Earth looked like. So buckle up and let's find out. Once upon a time, way back when Earth was just a baby, around 4.5 billion years ago, hopping into a time machine and paying a visit would have been a big mistake. The whole place was a hot mess. First of all, the ground was still all gooey and molten, so landing your time machine would have been a major risk. Now, as soon as you tried to get out, you would see a completely different Earth compared to what we know today. The landscape is a patchwork of rugged mountains, sparkling seas, and vast stretches of land. Picture massive volcanoes erupting in fiery bursts, shooting gases and ash into the air. It's like a crazy fireworks show. And even if you had a fancy new machine that could hover and had special shields to handle the heat, you'd still have a hard time breathing. You see, the early Earth's atmosphere is a bit moody. Thick clouds hang in the sky, casting mysterious shadows on the land below. The air is as thin as a whisper and filled with all sorts of interesting gases like hydrogen and helium. Carbon dioxide swirls around, giving everything a vibrant green hue. Water vapor drifts through the air, creating a sense of humidity and a refreshing mist. Oh, and there might be a hint of ammonia and methane just to keep things interesting. Lots of cool gases, huh? But wait, there's something missing. Oxygen. So if you take a deep breath, you won't feel that familiar rush of air filling your lungs. On land, there are no lush forests or towering trees just yet. Instead, you find rugged, rocky terrains. Some of these ancient rocks bear the marks of intense forces, collisions and earthquakes that have shaped the land over millions of years. But amidst all this ancient beauty, something amazing is about to happen. Life, in its early stages, is evolving and preparing for its grand entrance. Simple organisms, like algae and bacteria, rule the scene. They thrive in the oceans, using the abundant carbon dioxide to grow and multiply. The waters are teeming with activity, with colorful, microscopic life forms buzzing around like a busy city. These tiny organisms are working hard, releasing oxygen as they go about their business. They're like little factories, slowly changing the composition of the atmosphere. So this is what the early Earth looked like, more or less. But why was it so nasty? And how could it have changed so much since then? You see, Earth's heat came from all sorts of crazy things happening during its formation. First off, there was some serious heat already packed into the objects that came together to make our planet. Then, as Earth grew bigger and stronger, its gravitational force got a major power boost. It pulled in more stuff, but it also gave Earth a massive bear hug, squeezing everything tightly. And you know what happens when things get squeezed? They heat up like a pressure cooker. This crazy heating had a huge impact on Earth's structure. Picture Earth as a mixed-up bag of rocks, metals, and minerals. But as things heated up, the rocks and metals got so toasty that they melted. And guess what? The denser metals sank to the center and became Earth's core, while the lighter rocky stuff floated up to become the crust and mantle. It was like Earth decided to unmix itself, creating separate layers. Scientists call this wild separation differentiation. But the heating didn't stop there. With all this mixing and moving around, Earth got even hotter. It was like turning up the heat in a giant planetary oven. All this crazy heat had some serious consequences. Earth's high temperature made everything super speedy. Tectonic plates were dancing like there was no tomorrow, making the surface super active and full of geological shenanigans. Oh, and that's not all. Earth also got showered by some serious cosmic visitors. Imagine this. While Earth was busy gathering up all sorts of space debris during its formation, the rest of the solar system was causing some major chaos. Saturn and Jupiter decided to shake things up by changing their orbits, sending a whole bunch of massive objects hurtling towards poor Earth. These collisions were no joke. They packed a punch that melted minerals in Earth's crust and even vaporized them. These booms were so intense that they even blew gases right out of Earth's atmosphere. Talk about a wild fireworks show. Believe it or not, we can still spot ancient battle scars from these collisions. It takes some careful detective work, but we can catch a glimpse of their aftermath. For example, there's this place called the Manitsok Crater in Greenland. Even though there's no actual crater to see, we can examine rocks that were chilling 12.5 to 15.5 miles below Earth's surface back in the day. And guess what? They bear the marks of intense and sudden shock. Now that's some tough neighborhood. The wildest collision of them all was with a planet called Theia. Theia, about the size of Mars, crashed into Earth with a mighty BAM! It was a colossal event that changed everything. Theia's metal core fused with Earth's core, while the outer layers of both planets got shattered and tossed into space. The result? A beautiful ring of debris encircling Earth. Now here's the coolest part. That debris didn't just float around forever. It started to come together, like puzzle pieces finding their match. And voila, we got our very own moon. Can you believe it? And this incredible moon-making process might have taken as little as 10 years or even less. Crazy, isn't it? Scientists call this whole moon-forming extravaganza the giant impact hypothesis. So next time you gaze at the moon in the night sky, remember that it's actually a huge chunk of our own planet. And by the way, Earth also had quite the adventure trying to create its atmosphere. In the beginning, our planet's first attempt at an atmosphere didn't go so well. It had a thin layer of hydrogen and helium that came along with all the stuff it gathered. But those gases were like sneaky escape artists and decided to float away into space. Bye-bye, gases! Luckily, Earth didn't give up. It went for a second round, and this time it was much more successful. Volcanic eruptions came to the rescue. They spewed out all kinds of gases like water vapor, carbon dioxide, and a whole bunch of other funky ones. Even meteorites and comets joined the party, bringing lots of water and nitrogen to the mix. Earth's atmosphere was becoming quite the party. But here's the funny thing. There was no oxygen to be found during this second experiment. Nope, not a single breath of it. The oxygen that was produced by the sun's rays splitting water molecules got gobbled up by chemical reactions faster than you can say, oxy-bummer. It wasn't until Earth's third experiment came along, life, that things started to change. Photosynthetic organisms took center stage and used all that carbon dioxide in the air to make their food. And guess what? They released oxygen as a sidekick. Eventually, the organisms started belting out so much oxygen that it overwhelmed the reactions, and it began to fill up the atmosphere. It took a while, though, and it wasn't until about 350 million years ago that we got the oxygen levels we have today. About 21% of the air we breathe. So, from fiery volcanoes to mysterious oceans, this glimpse into the past reveals an Earth vastly different from the one we know today. It's fascinating to explore the ancient landscapes and imagine the early stages of life taking shape. Thanks to AI, we can catch a glimpse of Earth's remarkable history and appreciate the wonders of our ever-changing planet. So, stay tuned for more interesting journeys.
Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn. and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve: what caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth in its early stages and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the moon, too?
There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahamsa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous studies of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy. And according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Basically, everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't actually be tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e. absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too. And these blocks are called electrons and positrons. But what holds these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before. And according to the second law, these tiny invisible particles make up everything from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simply. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law 5. From only one fundamental universal constant, all the constants considered universal in contemporary physics are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So, this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept.
Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now you could literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them, but there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South Poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South Poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might.
In 2008, NASA had an intriguing question. How do spiders construct their webs in zero gravity? Therefore, they sent 2 spiders to the International Space Station. The first spider was the main participant, while the second served as a backup in case the first one didn't survive. However, things didn't go according to plan. The backup spider managed to escape from its chamber and visited its companion, resulting in a bit of a mess. They built tangled webs that interfered with each other. As if that wasn't enough, the flies that were supposed to be food for the spiders started reproducing faster than anticipated. Their larvae escaped from their container and covered the front window of the chamber. Over time, the spiders were completely hidden behind the larvae. Although this initial experiment didn't go well, one of the researchers involved in planning the spider experiment was still curious. In 2011, she got another opportunity to repeat the same experiment. This time, she sought assistance from other researchers. They decided to send a different species of spider into space and prepared 4 spiders, 2 for the ISS and 2 for Earth, allowing for result comparison. The goal was to expose the spiders to varying gravity conditions and observe their behavior. However, another twist appeared in the story. Initially, they believed they had 4 female spiders, but it turned out that 2 of them were actually males. Determining the sex of young spiders can be tricky, but fortunately, one male had already been sent to space, while the other remained on Earth, enabling valuable data collection. The second experiment proved successful. The spiders were active. They built and dismantled webs, and even without the assistance of gravity, they spun new ones. 3 cameras captured thousands of pictures, showcasing their hard work on the webs. Interestingly, it seemed that spiders created significantly more symmetrical webs in space than on Earth. The center of the webs was closer to the middle, and surprisingly, the spiders didn't always position their heads downward as they typically do on Earth. However, one significant factor made all the difference: light. When the spiders on the ISS had a source of light, they weaved asymmetrical webs, similar to those found on our home planet. Light played a crucial role in orienting the spiders in space. The chamber's lamps were attached at the top. If the lights had been positioned differently, for example on the side, it would have been challenging to observe the effect of light on the symmetry of webs in zero gravity. When the lights were turned off, the spiders rested in random orientations within their webs. Yet with the lights on, they would orient themselves away from the light source, which meant downward. Hence, in the absence of gravity, light assisted them in orientation. This discovery was unexpected, because spiders can typically build their webs in the dark and capture prey effectively, even without light. Spider's web itself is such a cool thing wherever they are. It's like these creatures have small silk production factories inside them. Within their body, a thread is stored in the form of a highly concentrated liquid. And a regular garden spider can produce up to 7 different types of silk, each having a unique combination of proteins. Each type of silk has a different purpose. For example, one type of thread makes the web elastic, which means the web absorbs the impact when insects collide with it. Another type of silk makes the thread flexible and strong, so it's more difficult to break. Some proteins found in the silk protect it from harmful bacteria and fungi, allowing the web to last longer. They also keep the silk moist so it doesn't dry out. Wow. Imagine having a home where you don't have to buy anything extra to maintain it. Spider silk is lighter than cotton and incredibly thin, up to 1,000 times thinner than human hair. But it's also insanely strong. I mean, it must be, since that's what they rely on while living their everyday life. Whether they're preying on some wandering insect or trying to resist heavy rain and wind. But you wouldn't expect it to be stronger than steel, right? Of course, in reality, you don't come across steel that thin. But if you could find a piece with the same weight as spider silk, you'd see that it has similar strength when pulled or stretched. In fact, spider silk is 5 times stronger than steel of the same thickness. Spider silk is also super stretchy, able to stretch up to 4 times its original length without breaking. Plus, it remains strong even in freezing temperatures below -40 degrees F. The most common type of spider is the orb weaver. They're masters at building those webs you keep seeing in open areas. That's where they have a better chance to catch a tasty lunch. But since they choose such spots, their webs are more prone to damage. That's why these spiders have a fascinating habit. They often rebuild their entire webs every day, even if the current web seems perfectly fine. I wish I was this dedicated to maintaining my bedroom. These spiders actually do this because they want to be prepared for the evening when they patiently wait for their potential prey to get caught in their carefully set trap. At first, this might seem like a waste of time. After all, they need to invest a significant amount of protein to produce the silk that forms their webs. But even if an orb weaver spider doesn't catch its meal overnight, it usually has enough silk proteins to dismantle its old web and build a new one for the following night. As the spider removes the old web, it consumes the silk at the same time, and by doing that, recycles the proteins it contains. If you've ever observed a spider on its web, you must have noticed how attentively it responds to even the slightest vibrations. It turns out that spider silk can be finely adjusted to different sound frequencies, unlike any other material. When a spider builds its web, it doesn't just spin the silk and leave it as it is. The spider actually makes adjustments to the silk by changing how tight or loose it is, and how different threads are connected. This way, it creates a web that can vibrate or make different kinds of sounds. The spider is like a musician tuning their guitar. This feather-legged lace weaver is called the garden center spider because it mostly enjoys humid greenhouse conditions. And it has a really cool way of catching insects. Instead of spinning sticky webs like other spiders, it uses electricity. It produces incredibly thin silk, almost at the nanoscale. And on its hind legs, this spider has special hairs that act like tiny combs. As the silk emerges from its body, the spider uses these hairs to comb and manipulate the silk. And here's where the magic happens. This process generates an electric charge. The threads of the silk are now crackling with electricity, so they come together to form little poofs that resemble fluffy balls of wool. These electrically charged poofs are a great way to trap innocent insects wandering around. When unsuspecting prey comes into contact with them, the electric charge causes the threads to cling to their bodies, making it almost impossible to get away. Female Darwin's bark spiders make gigantic webs that can stretch over rivers and lakes, which means they can reach over 80 feet across. It turns out such enormous webs are just a part of their genius plan to catch their prey. A super strong web that goes across the water like a bridge can capture large insects that gracefully fly above the water's surface, like dragonflies, and it's an impressive project that takes days to construct. These special lines go across the river and anchor the web firmly to each bank. There's no easy way out of this.